In my previous video, I introduced a new method for solving quadratic equations without using a formula. I pitched this as a competition against the traditional completing the square method, and in that video I said that one of the issues with completing the square is that you have to divide through by the coefficient of x squared to get the x squared term on its own. It has been pointed out to me that that's not necessarily the case, and there is a way of reducing the quadratic that doesn't necessarily mean introducing fractions. As such, the completing the square method does become a bit more competition for my method. As such, I've decided to pit them head to head in a task to let you judge which one you think carries it out best and which one's simplest. The task I've chosen is to take the generic quadratic equation, the ax squared plus bx plus c equals 0, and apply both methods to it to see which one comes out with the quadratic formula in the simplest way. Now, what we have on screen at the moment is the method that I have created. Now, if you haven't actually seen the previous video, some of this probably won't make a lot of sense to you, particularly the bits starting with y equals and y squared equals in the middle. So if you haven't seen the video, I would strongly recommend you go and see it before you watch this, or this isn't likely to make much sense. I will leave a link to that video in the description of this one. If you have seen it, then you can probably see what I've done there. This is designed to be what a typical person that's practiced in the method would write down to derive the equation, the formula. So it does miss out certain steps that are basically always the same, which is why it can be a bit hard to follow if you don't know the technique. But as you can see, we started off with the scaling technique, then factored out the x multiplied by 2a. The y is the substitution. That gives us the y plus b, y minus b, which is the difference of the squares part, which is taking the b squared across, and then we just rearrange the substitution terms of x and plug in the y value, and we've got the answer. Now, hopefully, if you have seen the video and are familiar with the technique, that will make sense to you. And to look at the alternative completing the squares method. Now, once again, I have put down here what a typical person who is familiar and practiced in this method may put to extract this formula, so that it's a fair comparison with what I put before. But again, there are certain bits in this which probably don't make sense if you're not aware of this reduction method. You probably can't see, for example, how you go from the second to the third line. So I haven't got a video for that one, so I'm just going to briefly explain what is actually happening here. If we take this second line, which has been scaled in the same way as I would normally, what we're first of all doing is multiplying everything by 2a, the coefficient of x squared. If we now move the brackets slightly, we can see we get a few 2ax's coming out. So we're going to put a substitution in, that's y equals 2ax, which means our formula now becomes y squared plus 2by equals minus 2c 2a. Now, if you look at that compared to what we've got at the top of the screen, what we started with, you notice that what we've actually done, apart from changing the letter from x to y, is you've basically multiplied the constant term by the coefficient of x squared and then removed that coefficient. That will always be the case with this method by using this substitution of the coefficient of x squared times x, in this case 2ax. So now we know what we've got, we can go back to our summary screen, and now you should be able to see how we get to that third line. From there, it's a matter of completing the square, which obviously the y plus b squared, y plus b all squared gives us the y squared plus 2by bit, and then of course it throws out a negative b squared, which we've taken across the other side to make positive b squared, which is why we have the right hand side as it is. And from there it's a matter of rearranging slightly to get in terms of y. And then of course, because y was 2ax, obviously x would be y over 2a, so that is how we calculate our final value of x. Now in a moment I'm going to put both of these methods up next to each other so you can compare them side by side. But first of all, I'm just going to look at one other potential way of getting to the formula, which is using Lowe's formula. Well, actually, Professor Lowe created a method, a way of solving quadratic equations. But ultimately, if you work out his method by a formula, this is what you actually get. And this x equals m plus or minus root m squared minus c over a is actually the quadratic formula, just with the substitution m equals minus b over 2a taken out. If you would substitute that minus b over 2a back into m and put it all over a single denominator, you would get the quadratic equation as it's shown here. Now, it's at first sight it does appear easier to remember than the quadratic equation, but I'm not really sure it particularly is, because the first part, the m, is just the first part of the quadratic formula, the minus b over 2a. It's fairly easy to remember that 2a is a common denominator. Denominators go straight across, and then because they're both plus or minus square root, so it's really only a matter of remembering what's in the root, which is m squared minus c over a or b squared minus 4ac. And I wouldn't really say there's a lot of difference between those two. And if you do use Lowe's formula rather than the quadratic equation, there may be a fair bit of simplification and work to do afterwards to actually get your values, because they may not join together too neatly without a bit of work. So yeah, I wouldn't really recommend that technique. So, a little summary. This is the two basic methods I'm proposing. Now, there's not really much to choose between these two methods. They're both about the same in complexity. And I would say someone that's fairly practiced in either of these methods could extract the quadratic formula from the generic equation in under a minute. Which kind of begs the question, is it actually necessary to be memorising this quadratic formula? When people are first taught to solve quadratic equations, they could just be taught one of these two methods. I would say the difference of squares method would be easier to teach, but then again, because I may be biased, and then when they get used to that, they could then extract the quadratic equation to use for further examples. But please let me know which of these you prefer and any other comments you may have. Thank you and goodbye.